Hi everyone and welcome to this new section in engine propulsion. In this case we will be discussing jet engine properties. So, definitions and overview. First of all, we should consider different variables such as temperature, which we'll be discussing as T, pressure P, and the velocity of the fluid. Okay? So the idea for a jet engine is actually that you have some air from the surroundings of the aircraft which is intaken, okay, which is put inside of the engine, and then it is compressed. Okay, this is done by the compressor. We will discuss this in further detail in a bit. Okay, but the idea is that the air is intaken, then compressed, then in the combustion chamber we get a higher temperature, okay, because of the mix with the fuel. And after that we have the turbine, where the mixture, which will be air and some fuel, okay, is actually expanded. So this means that the pressure is actually reduced in this case. Okay, compressor increases the pressure and the turbine decreases the pressure. Okay, and finally we have that the mixture is expanded again through the nozzle. All right. So the idea in this case is that we obtain actually higher velocities. All right. Let's see the different components. So we have the inlet, which is basically this part over here. In a turbojet we have a kind of a basic inlet. In a turbofan we would have a more complex inlet, okay, which we will discuss in a bit. Then we have the compressor, where we have an increase of the pressure, as we mentioned. The combustion chamber over here, which is this part over here, okay. The turbine, and finally the nozzle, all right. In addition, we have a shaft in the middle, okay, which actually relates the movement or the rotation of the turbine to the rotation of the compressor. So the movement of the turbine, because of the combustion chamber, we get a higher temperature of the fluid, all right. So this implies a higher thermodynamic status, and therefore we actually gain some movement on the turbine. So as a consequence of the combustion chamber, we get a rotation in the turbine, and the turbine, therefore, because it is connected to the compressor, actually moves the compressor. Okay? So the idea initially would be that the compressor is stopped, is completely still. Okay? Then we have the combustion chamber. In this combustion chamber we get more or higher properties, thermodynamic properties. Therefore the turbine starts to move, and because it is connected to the compressor starts to move again. Okay, so this is the kind of cycle, and once the compressor starts moving, as you can imagine, the machine, the engine, works optimally. Okay. Now, the idea of the thrust that is generated by this kind of engines is actually that the exhaust velocity, okay, so the velocity which is expelled, is related directly to the thrust, and also the mass flow, okay, which is propelled, is also related to a thrust. So another way of saying this is that the thrust is a direct consequence of the amount of flow propelled, which implies the air and the fuel, okay, the mixture that we had here. So the amount of mass, the amount of kilograms per second, okay, that we are expelling, multiplied by the velocity of ejection. Here we have the velocity of ejection minus the velocity of the aircraft, because this velocity will be relative to the velocity which we took in, okay, in the inlet of our engine. So the idea is just this, okay, the difference of velocities multiplied by the amount of flow which is propelled, okay. This is the thrust. This is the basic definition of thrust, okay. Here just an overview of the different kind of jet engines. We will speak of each one, okay. We will discuss several of the properties that each one have, okay. As you can see, the turbojet is like the basic model. Then you have the turbofan, which is kind of a combination, as you can see, it's turbojet, okay. It has kind of a turbojet structure, and also it has an additional fan, which is common in almost all commercial aircraft use turbofan, okay, because it's more efficient. and as you can see there's a fan, okay, which acts also as a kind of a compressor, and there's an air which goes on the outside and an air which goes in the inside, okay, so we will distinguish between cold air and hot air. Alright, this is kind of a more complex machinery, as you can imagine, compared to the turbojet. And finally we have the turboprop, which is kind of similar to the turbojet, but the idea is that the amount of thrust is actually not as a consequence of the exhaust itself, not as a consequence of the velocity of ejection, but rather because we are moving the shaft, as we mentioned before, we are able to move a propellant, okay, a propeller. So this is what generates the most amount of thrust.